Hello, welcome back in my friend's workshop. Our previous video we introduced our new Integra E2 cylinder, which has a number of functionalities to help you stop wasting gas. In this video we will focus on flow control. So why have we chosen to discuss flow control today? Well, not only is a considerable amount of gas wasted by selecting the incorrect flow, excessive flows actually can affect negatively the quality of the weld. Our experiences from visiting customers is that flow rates are often poorly controlled and therefore lead to considerable excessive gas waste. After leaks, which we covered in our first video, excessive gas flow rates is the second highest contributor of gas waste. How can this happen? The main contributor for this is the use of a traditional pressure regulator connected to a standard cylinder. Let's examine closely this standard pressure regulator. The first gauge from the regulator is the cylinder's contents gauge. The second gauge from this regulator is intended to read the flow, which can be set by turning this black knob. Often we find regulators where it is impossible to read the flow anymore because the gauge and indicator didn't survive an earlier fall. Likewise, sometimes readings from the flow on the gauge can differ quite significantly from readings of the flow measured at the torch. So flows are often regulated in a very uncontrolled way. Also, higher flow rates are wrongly considered to give a better weld result or safeguard you from the bad effect of drought. But nothing is further from the truth. As you know, for every welding application, there is an optimal gas flow. Also, the flow may even be documented in your welding procedure specification or WPS. So we better stick to these optimum and documented flows. Let's look at the Integra E2 cylinder and how we ensure the optimal flow conditions. As I mentioned in the earlier introduction video, the Integra cylinder is fitted with an integrated regulator. So we save time connecting the regulator, searching for the spanner, doing leak tests, etc. every time we use the Integra cylinder. You operate the Integra cylinder, E2 cylinder, by using the power arm, which is located here. This again clearly distinguishes the new Integra E2 cylinder from the previous generation Integra cylinders. The power arm has three positions. The first and lower position is the off position. Off means the regulator is closed and there is not any flow. This is the position to transport and store the cylinder and how it will arrive at your workshop. The second position is the eco position. This eco position is our default setting for welding. Putting the power arm into this position is the norm and ensures optimal working conditions and maximum gas savings. The last and third position is the plus position. This position will be used for specific conditions where we want to boost our gas flow. We'll cover this later. As I said, our default and preferred position for welding is the eco position. The next important component for proper use and operation of the Integra cylinder is the IFO. The IFO is a precision engineered device which is used in conjunction with the Integra cylinder that connects to your gas hose from the welding machine and that gas hose to your cylinder. IFO means Integrated Flow Optimizer, and as the name suggests, this optimizes the flow. So the IFO is more than just a simple quick connector. We have a range of IFOs specific for use with this Integra E2 cylinder, which we color in green to distinguish them. The range allows the user to select different preset and fixed flows for different applications. The IFO has a reference number which identifies the fixed gas flow. The flow ranges from the E6, which is used for lower flows, in this case 6 liters per minute, through to the E18, which gives an indicative flow of 18 liters per minute. For the most common welding applications, MIG, MAG and TIG, flows between 6 and 18 liters per minute are sufficient, so no excessive flow above maximum 18 liters per minute can be set. Why did I say indicative flow? This is because, as with any welding setup you can find, flows are affected by the maintenance of your torch and welding system. Different machines will give different flows at the torch, regardless of the setting, due to the back pressure. As an example, when I connect one of the IFOs, for example the E12, and then measure the flow at the torch, we should have a flow of normally around 11-12 liters per minute. And this reassures me that my welding machine and torch are in a good condition. If, with the same E12 IFO, I get a flow at the torch of only 5 to 6 liters per minute instead of 12, this indicates that the setup needs to be reviewed. Checking your flows at the torch, as you know, is best practice and applies to Integra E2 cylinders or first generation Integra cylinders, as well as any traditional cylinder setup with a standard regulator. We would always encourage users to check the actual flow rate at the end of the torch shroud, either by using of a normal standard manual flow tube, or what we may call the pea shooter. Any field-based application specialist would all carry with them the calibrated digital flow meter like these, and are happy to set up your system initially by use of the digital flow meter. As a reminder, what we spoke about here was based on our Integra E2 positioned in the eco position. Okay, we're ready to give it a try. We start by selecting our IFO. Imagine that I would do a weld of about a 4 mm carbon steel plate with a 1.0 millimeter solid wire and set up my machine probably at 150-160 amps. My desired flow is 12 liters per minute. Therefore, I am selecting the IFO labeled E12. I connect my E12 IFO to my gas hose. I connect the IFO to the cylinder. Plug and play, easy and quick. I position the arm in the eco position. I take my torch, connect it to the digital gas flow meter. I pull the trigger and I see my flow reading is 12 liters per minute. Nice. A quick double check, connecting a E15 IFO, which should give me a flow at the torch of 15 liters per minute. Disconnecting the E12 IFO, connecting the E15 IFO to my gas hose, putting the power arm in the echo position. I connect the digital flow meter to the shroud of the welding torch. I pull the trigger of the torch, and what do I see? I read exactly 15 liters per minute flow. All works fine. We can start welding. But before I do, remember, we will bring you other webcasts soon talking about the other features being surge protection and flow consistency, as well as the integrated information functionalities. Thanks and see you soon.